Last week we defined two kinds of friction. One was called static friction, one was called kinetic friction. Another word for kinetic friction would be sliding friction. Yeah, that's the word I like to use, even though that's not used very often, kind of in books and stuff. I like to use that one because to me that describes it better actually than kinetic friction. But what's the other one beyond that? Dynamic friction. You see those two pretty often. Kinetic friction, dynamic friction, but my favorite is sliding friction, like I said, because it describes it better, I think. Can anybody tell me what the difference between static friction and, we'll call it kinetic friction here? What the difference is? Both of them are forces of friction. Both of them are resistive forces. What does that word resistive mean? It resists motion. Static friction is a force that resists motion. Go ahead. Yeah, good. When the object is at rest, it keeps it from moving. Right? If I push on an object and it doesn't move, then the net force has to be 0. And if the net force is 0, but yet I'm pushing on it to the right with a force of 10, something's got to be pushing back with a force of 10. That's static friction. The wacky thing about static friction, we talked about this last week, the crazy thing about static friction is that it changes. It's like it's got a mind of its own. Sometimes we call it the lazy force, because it responds to whatever I push with. If I push with 10, it pushes with 10. I push with 15, it pushes with 15. It only pushes as hard as it needs to push. Doesn't go any higher. I push with 10, it pushes with 10. I push with 15, it pushes with 15. I push with 19, it pushes with 19. I push with 20, oops, it moves when I push with 20. What's the force of static friction when it moves? How much is static friction when that desk just moved when I push it with 20 newtons? How much is static friction, Cody? No, 0. Static friction is 0 when it moves. Now, if the maximum force that I could push with before it began to move was 20, basically, okay, then that means the max force of static friction was 20. Doesn't mean that's what it is now. Hey, once it's moving, static friction is 0. But if that's how hard I have to push to get it moving, then that's the maximum force of static friction. It's that lazy force, right? It can push with 20, but it's only going to push with 20 if it needs to. Okay, it's kind of like lots of kids in junior high school. You know, look, I can work harder. I can study harder. I can do more homework, but I'm only going to work as hard as I need to work. Okay, that's what happens in junior high. Sometimes in senior high too, right? Okay, we only work as hard as we need to work sometimes. Okay, that's static friction. It can push with 20. It's got lots of potential, but only pushes as hard as it needs to push. It does whatever I'm doing until it reaches the maximum value. Kinetic friction, hey, once it starts moving, kinetic friction, nice thing about this one is it's constant. If I push with 19 newtons, doesn't move, I push to 20 newtons, it barely gets it moving. There is no static friction, but now there's kinetic friction. Maybe kinetic friction is 16. If kinetic friction is 16, the nice thing about it is it's going to be 16 as long as this object moves. No matter how hard I push, no matter how fast it moves, okay, it's going to be, if it's 16, it's going to be 16. Notice in that last example that I gave you, static friction maximum was 20. And of course, depending upon the situation, it might not be 20. Kinetic friction was, I said about 16. Why did I pick 16? I made those numbers up, right? But why did I pick that number 16 over, say, 25? Good. Kinetic friction is smaller than the max force of static friction, right? Static friction in that whole scenario could have been 5 or 10 or 15, depending upon how hard I pushed. 16 is not smaller than any of those, but 16 is smaller than 20. It's smaller than the max force of static friction. Got it? All right. We got two equations that we learned last week. First one was for the maximum force of static friction. It was equal to mu times the normal force. I discovered, with the help of somebody else, that with one of you guys that came up after class and asked me about this, I discovered that there's a typo in your data sheet. Everybody take a look at your data sheet right now. I want to point out that typo that was so thankfully pointed out to me by a student, by one of you guys. If you take a look down under dynamics, you see the second equation that says FSF max equals mu K times Fn. Shouldn't be mu K, should be what? Mu S, right? The coefficient of static friction. And then, of course, kinetic friction is equal to mu K times the normal force. What's mu stand for? Mu S or mu K? It's a Greek letter, right? Greek letter like alpha, beta, gamma, delta. It's mu. Yeah, it's mu, but what does it stand for? What does it mean? Yep. Yeah, it's the coefficient of friction, and it basically tells us how much two things stick together, right? How much these two materials stick together when they rub against each other. Okay, the higher that value is, the more they stick together, obviously. Remember, this one, as long as the object is moving, this one gives us the exact value of kinetic friction. This one doesn't give us the exact value of static friction. This one gives us the max value. So in the problem right here, okay, the value that I would get out of this equation would be the 20. But if I push with 5, the force of friction isn't 20, it's only 5. If I push with 10, it's only 10. If I push with 15, it's only 15. This doesn't give me those values. This just gives me the maximum possible value. All right? You guys worked on a couple questions in class on Friday, and then you had one question for homework on Friday. The homework question was page 187, question number 1. I want to go over that question now. It says, an applied force of 450 newtons forward is needed to drag a 1,000 kilogram crate at a constant speed on a horizontal rough floor. What's the coefficient of kinetic friction? All right, you know what? I want to scratch this out for a second. We're going to look at that again in a second. I want to look at the first sentence here initially. If we didn't see the word kinetic, notice, in this problem, if we did not see the word kinetic in this problem, how would we know that this is kinetic friction, not static? All the problems we did on Friday, remember, were static. How do we know this is kinetic or sliding friction? Can we? It's getting dragged? Yeah, okay. But you can drag something and not move it too, right? Or at least attempt to drag something. What about this? An applied force of 450 newtons is needed to drag it at a constant speed. How would that have been phrased on Friday with the static friction problems? How would the wording of that have been different on Friday? An applied force of 450 newtons is needed to get a 1,000 kilogram crate moving, or it's that much force is required to cause it to begin moving. That makes sense? We're not causing it to begin moving now. That's not the force we need to get it moving. This is the force that we need to keep it moving at a constant speed. Does that make sense? If it's moving at a constant speed, it's kinetic friction. It's kinetic friction. So we're going to say that, look, this is the applied force, 450 newtons. But if it's moving at a constant speed, the net force we know has to be 0. If it's at rest or at a constant speed, the net force is 0. And if the net force is 0 and I push with 450 that way, then friction has got to push with 450 that way. If it was accelerating, we wouldn't know the force of friction. But since it's moving at a constant speed, we do know the force of kinetic friction. It's negative 450, although I'm going to only record the absolute value of it, or the magnitude of it. We got a mass of 1,000 kilograms here. And we want to find the coefficient of kinetic friction there. The equation that I use for kinetic friction is this. What did we say about the normal force in all of these problems, for now at least? What's the normal force going to always be equal to until I tell you differently? Good, m times g. So we're going to say kinetic friction is mu times m times g. We're looking for mu. So mu is going to be equal to force of friction divided by m times g. It's going to be equal to 450 divided by 1,000 times 9.81. And when you do the math there, we should get 0.0459. No units, because coefficient of friction never has units. How many people got that number, 0.0459? Does it make sense why it's kinetic friction, not static? I mean, clearly, they asked me for the coefficient of kinetic friction. But if they didn't, right, it's a difference in the wording of the question. This much force is required to get the object moving, to cause the object to start moving. That's static. This much force is required to keep it moving. That's kinetic or sliding friction. Take this one. Here's one you're going to like. This one says, unfortunately, it's not in your book. This one says a 10-kilogram object is at rest on a surface that has a coefficient of static friction of 0.95 and a coefficient of dynamic or of kinetic or of sliding friction, good, of 0.65. We want to know the force of friction if 50 newtons is applied and if 300 newtons is applied. Good question. Tough question. First of all, how do we know what kind of friction it is? We need to know the type of friction if we're going to calculate the actual value of the force of friction. How do we know what kind of friction it is? How do we know if this object moves or not? It's at rest. I push on it with a force of 50 newtons. Does it move? If it does move, we're dealing with kinetic friction, right? If it doesn't move, we're dealing with static friction. Any ideas to figure out whether it moves or not? Let's go back to the example that I gave you when we started this today, and the example, the slightly different example that I gave you when we started this last week. This desk is at rest. There's no net force acting on it. I push on it with 5 newtons. Doesn't move. What's the force of static friction? 5. Push on it with 10. Doesn't move. Static friction is 10. Push on it with 20. It barely begins to move. The maximum force of static friction was 20. If I push on it with 10, I know it's static. If I push on it with 30, I know it moves, and it's got to be kinetic. What we have to do is find for this question the value of the max force of static friction. In other words, what's equivalent to the 20 in the example that I just gave you. How are we going to find the max force of static friction? FSF max is equal to mu static times the normal force. So we're going to say it's 0.95 times the normal force of 10 times 9.81, right? M times G. And when we do that math, we get 93.195. The maximum force of static friction. This isn't my answer. Listen, I'm just telling you right now, this is how hard I need to push to get it moving. This isn't necessarily how hard I'm pushing. This isn't necessarily the force of static friction. Remember, it's the max force of static friction. Now, let's go back to question A. Does it move in question A? The max force of static friction is 93. I push with 50. Does it move? Zach? No, it doesn't move. I'm not pushing hard enough. Look, it's a lazy force, this static friction. It only pushes as hard as it needs to push, but it doesn't need to push very hard here because I'm not pushing very hard. I'm pushing with 50. It says, hey, I can do that. I can push with 50. I can push with 93. It's easy for me to push with 50. Static friction is what keeps this thing from beginning to move. Now, what's the value of friction? First of all, let's identify that it's static friction. And then let's figure out what its value of static friction is. I'll give you a hint. It's staring you right in the face. It's literally staring you in the face. What is the value of static friction in this question? Yep, 50. Okay, question A, the answer is 50 newtons. Why? Why, Miles? Good, good, said it perfectly. It's a lazy force. It only pushes as hard as I push. unless I exceed the maximum value. Right? Then it can't push that high. Okay. Listen, I'm only pushing with 50. It could push as high as 93, but it's not going to push with 93 because it doesn't need to. It's a lazy force. It only pushes with 50 because that's all I'm pushing with. All right? So get the max force. If that value is less than the max force, it doesn't move. Static friction. Static friction value will be the exact value that I push with. Now, what about question B? Does it move in question B? Kenzie? Yes, it does. So what kind of friction do I have? Good. How do I find the value of kinetic friction? Now that we know it moves, right? 300 newtons easily exceeds 93.195. It moves. What's the value of kinetic friction? Just go what? Nope. Mouse? Yeah. The equation is kinetic friction force is equal to mu k times the normal force, right? Listen, this stuff only gives me static. If I exceed the maximum static friction force, I got to figure out what the force of kinetic friction is. Mu is 0.65. Fn is 10 times 9.81. Before I even figure out what that value is, I am 100% sure that it will be less than 93. If it's more than 93, I've made a mistake. Why am I sure that it's going to be less than 93? Cody? Kinetic force has to be less than the maximum static. Okay, this one doesn't have to be less than 50. It just has to be less than 93. Okay, so let's figure this one out now. We see 0.65 times 10 times 9.81. Sure enough, it gives me 63.765. Which we're going to round to 2 digits, 64 newtons. So look, kinetic friction wasn't smaller than static friction. Static friction was only 50. But kinetic friction was smaller than the maximum static friction of 93. Right? You're going to have a quiz tomorrow. It's not on this. Just on Newton's first law and Newton's second law. Maybe a free body diagram. But in a couple of days, you're going to have a quiz on this. Okay, and the question you're going to get is going to be something like this, except it's not going to be an A-B quiz. It's going to be an A-B-C-D quiz. And I'm going to give you like 4 different forces that we push with. And basically what we're saying is for each of those, you have to identify whether it moves or not. If it doesn't move, the answer is just the applied force. If it moves, it's kinetic friction. You got to figure out that value of kinetic friction and write it down. Hey, if for 3 of them it moves, the answer is the same for all 3, right? Okay, what if I pushed with 600 newtons here? What if I push with 600 newtons? Would it move? Yes. What's the force of kinetic friction if I push with 600 newtons? It's 64 newtons. Okay, it doesn't matter how hard I push, kinetic friction will always be the same as long as it moves. Right? Make sense? Okay. I got a few questions for you to work on from your textbook, some check and reflect questions. Then I got a little worksheet for you to work on after your textbook questions. We'll give you the textbook questions now, maybe in an effort to save you from having to take your textbooks home with you tonight. Questions I want you to work on page 190, number 1 to 6 and 10. And when you finish that, you can pick up a copy of the worksheet and work on those questions as well.